all of us started off as an embryo. Everyone in this room started off as a small cluster of about 200 to 300 cells that look and act exactly the same. These cells are where every single cell in our body originated from. But then I found it puzzling that our nerve cells started off from the same place that our muscle cells did, when they are very different. An animal first begins life when two cells meet, the egg and the sperm. These two cells are very different. For example, the sperm cell is the smallest human cell in the body, while the egg cell is the largest. But the one thing these two have in common is that they both only hold half the genetic material found in a normal cell. So when they meet, they should have the expected amount of DNA. This cell undergoes division, first into 2, then 4, and so on. These cells classify themselves as embryonic stem cells, or more simply, just stem cells. The term stem cell encompasses various cell types, but they all have the unique ability to differentiate beyond their original form and acquire specialized abilities. Now, as we grow in the womb and eventually become born, most of our cells have been specialized and have lost their ability to differentiate. These cells are called adult stem cells. These cells can only differentiate specific cell types. So in our bone marrow, they can only differentiate into different types of blood cells. Now that I've talked about this, I would now like to move on to what I find the most fascinating aspect of my discussion: the use of stem cells in medicine. That is based on the notion that we can substitute an individual's damaged cells with another person's correctly functioning ones. So a person with type 1 diabetes has damage to their insulin-producing pancreatic cells, or a person with paralysis may have damage to their nerve cells. It would be wonderful if we could aid these people. And we can. Embryonic stem cells are available, and we could extract and cultivate them, and we could guide these stem cells to differentiate into the specific cell type we need, and then administer them to the patient. Now, you may be thinking, wow, this girl loves stem cells way too much. And you wouldn't be wrong, but I also think you're in awe about how amazing these cells are and flabbergasted by the potential they hold. Thank you so much for listening.
Thank you so much, Anushka. Again, showing set of future directions. Where could this go? You don't have to answer this, but you will have to answer questions from our judges. Let's go over to Adam.
Thank you. It's a really nice explanation, really complicated topic, which sort of leads into my question, really. How did you decide what to put into the 3 minutes, given how vast the subject is?
Well, I rewrote my speech quite a few times. This isn't the one I did at the school final, but I think my dad helped a lot because he loves stem cells way too much like me. So he helped a lot, and I think it was just because there's so much to talk about, I just chose something. I just chose where they came from, and then what I found the most interesting was what you can do in medicine.
Yeah, thank you.
Thank you, Adam. Jo, would you like to ask a question?
Yes, it is such a big topic. What did you leave out that you would really have liked to have included?
The ethical issues, because there's a lot of ethical issues surrounding stem cells. So I would have loved to talk about that, and also I would have, because I've been doing research after that for the questions. So the other day I found out that we're trying to convert stem cells in our cells in our skin back into stem cells. So instead of taking them from the embryo. So that would be very promising. So that would be like another way to avoid the ethical issues.
Thank you very much.
Brilliant. Thank you very much. Anushka, congratulations. Well done. And you can go back to your seat now.